In this R tutorial video, we're going to learn how to calculate descriptive statistics and also display numeric variables. So first I'm going to bring in my data set, which is the medical data, and I'm going to shorten the name to be just med. And the variable we're going to be looking at is actually the BMI of these 155 patients. So BMI is a numeric variable. We can describe its center with either the mean or the median. So to calculate the mean in R, we just can use the mean function and then give it our data frame name $ variable name. And we can see a mean BMI of 32.9. Similarly, if we want the median, we can just use the median function and give it the numeric variable, and we see BMI has a median of 31.6. Now in terms of spread, the standard deviation can be calculated with the function SD, and we see a standard deviation of 7.3. And we also can describe the spread of this variable using the 5-number summary, which in R, we can just use the 5num function. So this 5num summary gives us the minimum BMI, the first quartile, the median, which should match what we saw before, the third quartile, and then the max BMI. So if we want to display this single numeric variable, we have a couple of options. First one is to make a histogram, and we can do that with the hist function. So the hist function just takes our variable that we want to display, BMI, and then I'm going to include some options. So I'm going to want to give it a main title to describe what my plot is showing. Also the X label needs to be changed to my variable name. And then one other option I need to include is to change the default of what R is going to do with the points that fall exactly on a bend endpoint. And to do that, I'm just going to say right equals F for false. Now if we run this, we're going to see a nice histogram of our BMI variable, which we can see has a slight positive skew. One thing we can change with our hist function is actually the number of bends or the number of breaks that our histogram shows, and I can do that by changing my breaks option and giving it a number. So if we wanted maybe larger bends, fewer number of bends, I might say breaks equals 5, and R will approximately give me 5 wider bends for this data. If I wanted to go in the other direction, I could ask for more breaks, and then I would get a smaller bend width. Notice each of these different histograms displays the data in a slightly different way. Typically you want between 5 and 15 overall bends. Another way we can display this variable is with a box plot, which again just takes the numeric variable you want to display, and then I'm going to again change the overall title, and actually the Y label will be our variable name. And we can see this box plot is literally a representation of our 5-number summary. So our bottom whisker here is the minimum value, the bottom of the box is Q1, the dark line is the median, the top of the box is Q3, and then we have either the top whisker or a couple outliers here that represent the maximum value. One advantage of the box plot is that it makes it really easy to compare the distribution of a numeric variable across groups of a categorical variable. And to show you what I mean, let's compare the BMIs of these patients based on their diabetic status. So a 0 here means the patient is not diabetic, a 1 means the patient is diabetic. And we can use our box plot function to ask for the BMI as a function of our grouping variable, diabetic. So this tilde here is basically telling R, take this variable as a function of this other variable. Again, we'll want to include our title and our Y label. Our X label is now going to be our grouping variable. And then instead of having the plot show up as a 0 and a 1, which wouldn't really mean anything, we can change those labels along the x-axis to actually say no and yes with the names option. So this grouped box plot gives us a quick look into how BMI, the distribution of BMI, differs across these two levels of diabetic status.